All right, guys. Today we're looking at Chapter 6. I'm actually recording this audio over top of the video because I didn't record audio the first time. So hopefully this one works. It might be loud. I'm holding the microphone right by my face. All right, Chapter 6 was about normal distribution. It was about binomial geometric distributions. So here at 6.1, again, pause it. Try the problem on your own before I start doing it. We'll see how this goes. This is really awkward. I'm staying up in the middle of my room, holding a microphone. It's awful. So now we're looking at the first question. Show the probability distribution for x is legitimate. Well, to be a legitimate probability distribution, all your probabilities have to add up to 1. So do these? Why, yes, they do. So all your probabilities. It's actually kind of nice that my face isn't in, so you guys don't even know what I'm doing. All right, let's make a histogram of this beast. The histogram will not be well made. You will see. I am a future. I will. You'll see. It's actually absolutely atrocious. But make sure you label. Just watch your screen. You'll see it. Oh, that's terrible. Awkward silence. Probability goes on the one side. At the bottom, you're going to put number of scores. Number of goals scored. Now and then we're going to take a look at it. And guys, never forget, when one door opens, another, oh, jeez. When one door closes, another one opens. Other than that, my car is pretty nice. So when you look at this picture, you should notice that it's slightly skewed to the right. What that means is you have those 9 and 8 and 7 goal games are pulling the average up higher, while there's actually most of the games are in the lower half of number of goals scored. Like most of the games were less than 4 or less. All right, now what's the probability that randomly selected game is at least 6 goals? It's easy. Go up to your chart and you just add up your 6, 7, 8, and 9 probabilities, and that will give you your solution. Boom, I told you. You guys didn't believe me, but that's what it's. So it's 0.061, right? All right, let's keep moving on here. All right, we want to find the mean of the random variable. Now, there's 2 ways you can do this. You can do it the longhand way, and you can do it the shorthand way. To do it longhand way, you do 0 times 0.061 plus 1 times 0.154 plus 2 times right? Multiply and add. I'm going to suggest you guys do list 1, list 2. Plug this in your calculator. If you forget how this is in lesson 6.1, they have the key shortcuts to do so, and they'll just give you your answer. Of 2.851, of course. Now let's interpret that value. This is actually the important part. And I don't do a good job of writing it, so now it's the time for me to shine. So what that means is if many random samples are taken of the random teams, the average, the mean of those samples will be about 2.851 goals. Okay, so if you take many random samples, the mean of those scores will be about 2.851 goals. I don't know what I'm talking about here. All right, here we go. Now, when we do standard deviation, I'm going to do it the same way. I'm going to be looking at using my calculator. Use my calculator, I get 1.63. And what that means is, on average, a randomly selected team's number of goals in a randomly selected game will differ, or we expect it to vary, by about 1.63 goals. Again, if we take a randomly selected team from a randomly selected game, we expect that the goals to differ by about 1.63 goals about the mean. Okay, that might not be what I'm writing. Sometimes it's better to listen to what I say than what I do. Oh man, my house needs. Yep. Guys, sometimes I miss my whiteboard at school. Do you know why I love whiteboards? They're just remarkable. All right, so let's look at weight of 3-year-old females. Some things I know about females: you never should ask anything that requires numbers from them. Age, weight, anything like that. All right, so now this question is nice because it says it's normally distributed. Once it says it's normally distributed, I know that I can do normal CDF and PDF on these type of problems. So now the first one asks, what's the probability that a randomly selected female weighs at least 30 pounds? Well, then I can do normal CDF. At least means that's my lower. I'm going from 30 to above. So I go at least 30 to 99999, comma, mean, which was 30.7, comma, standard deviation, which was 3.6. When I plug that in my calculator, I get 0.5771. So there's a 57.7% chance that a randomly selected female will weigh at least 30 pounds. Now we go to the next question. Pediatrician weighs a little 3-year-old girl, 25 pounds. Not my daughter. My daughter's double that. So should he be worried? So let's find out what percentile she's at. We're going to do normal CDF from negative 99999 or 0 to 25, because that's less than 25 pounds, 25 pounds or less. Mean is 30.7. Standard deviation is 3.6. When I plug that in my calculator, at 0.056673, which means the doctor should be worried because only 5.7% of females that are 3 years old weigh less than that. So that is a kid that we need to watch. Okay? .2, we're going to be looking at means and standard deviations and combining them for different distributed things. All right, so we're looking at males and females and their study habits. Have a score for that. You can read all about it. Pause it, read it, try it, love it, learn it, live it. So I guess I'll wait for me to start writing. All right, this is taking a while. I don't know what was going on. Unless the video froze. I hope not. There we go. Well, that was awkward, guys. I should probably just take that out. So, for A, so for A, why is it reasonable to assume the scores to students are independent? Because they were randomly selected. When you randomly select students, there's a pretty good shot. There's no reason that they should be the same. Again, I didn't write that answer. That's why it took so long. Now for B, what's the expected value? aka what's the mean? Mean, expected value are the same thing. My computer screen just went off. All right, it's back. All right, so you just subtract. female minus male. So you'd expect 15 to be the difference between a randomly selected male and a randomly selected female. All right? All right, so now for standard deviation, it's a little bit different. This is square root. You square your standard deviation, add it to the square of the other standard deviation. Doesn't matter if you're subtracting, adding, you always add in the square root. So we do 28 squared plus 35 squared, square root it. When I plug in my calculator, I get 44.8. So that's how much I expect randomly selected male and female to vary about the mean. We're almost there, guys. All right, from the information given, can we find probability that a woman is higher than a man? Let's see if I do this right. I know the answer. Do you? The answer is no. No, you cannot. The reason why you cannot is because if you go up and read the original problem, it does not say they're normally distributed. So you can't do normal CDF if they aren't normal. So you cannot draw a conclusion. Trick question. Gotcha. All right, let's go with swimming. We have a swimming team. Pause it. Try it. There's 4 members. We have their individual means. The question's asking, what's the chances if they have a relay team that their swim time will be less than 220 seconds? All right, so first thing we need to do on this one, we need to look. It's normally distributed. They're independent. We're good to go. We need to find the total mean. So what's the mean of all the swimmers combined? So to do that, it's pretty simple. We just add up all their individual means, and that'll give us the total mean. That's easy peasy. Now to find standard deviation, we're going to have to do something a little bit more difficult. We're going to have to do the square root of each piece squared, and that will give me the standard deviation of the group. Boom! 5 point some weird number. I think it's a 5, 6 is your standard deviation of the group. Now that I have a mean standard deviation normally distributed, I can go through and do normal CDF now. So I'm going to do normal I'm trying the probability that X is less than 220. So it's 220 and less. So what I'm going to do is normal CDF. Negative 99999, lower bound, comma 220, upper bound, comma. I'm trying to write in yellow because I'm fancy. Comma. Mean, which is 224.2, comma, standard deviation, which was 5.56. I'm going to plug that in my calculator. When I do, I get 0.225. So there's a 22.5% chance that their swim time will be less than 220 seconds when they combine forces on a randomly given swim meet. All right, guys. That was fun. This is about the time I start switching around, and I realized I go to the next page. I'm like, wow, this is going real swell. And I go to section 3, and I'm like, 6.3, we talk about binomial and geometric probabilities, PDFs. Make sure that this comes up in one of your unit for your response questions. And then I realized that the sound wasn't on, and I have to go through and re-record everything in the face. I was very, very disappointed. I was talking about pausing, trying, doing. But I think from here on out, you'll have sound, hopefully. Have a good day. Well, guys, I just realized that the last 15 minutes didn't record audio, so I'm going to have to go back in and redub it, but luckily you won't even know that because my face isn't in it, and that's why I do it this way. Hopefully you guys try this. Let's go. I have a long day ahead of me. Mamma mia. So what's the probability that x equals 5? Well, what do these all have to add up to? Well, 1. So all these bottom ones have to add up to 1. So probability is 5 is 0.1. What's the probability pain score is less than 3? So I just add up these two. I get 0.3. What's the probability that the pain score is greater than 3? I add up these two. I get 0.4. Ta-da! Pretty quick. And part D asks what is the mean. I guess I can actually just go down there. I think I have it on my notes. I do. So what's the mean? You do 1 times 0.1 plus 2 times 0.2 plus 3 times 0.3 plus 4 times... It's the same as your expected value, right? I got the expected pain score to be 3.1. Alright, sorry I went really fast through those, but I have to go re-record. Oh! It's the worst. Alright, this is where things get fun. Amarillo Slim, a professional dart player. That's not how you talk. Howdy, it's me, Amarillo Slim. I'm a professional dart player, and I have an 80% chance of hitting them there bullseye right in the eye with the dartboard at any throw. Suppose I have 10 darts, and I throw one at a time at the dartboard. What's the probability that Slim hits that bullseye exactly 6 times? Alright, so we have a number of trials, right? We have a n. We're going to do it 6 times. We have a probability, p. I'm sorry. We have a number of throws, 10. We have an x. We want to know what's probably he gets 6. If you look at bins, by B means is there, there's only 2 outcomes, right? Binary. It's either he makes a bullseye or he doesn't. I, independent. Every dart throw does not, it doesn't matter what he did before. Number, you have a set number of trials, 10. And S, same probability, yet it doesn't change with each throw. So I know for this one, I'm going to be doing binomial PDF because we're looking for probability at 1 point. And here you use NPX. So it's 10.86. Number of trials, probability, how many times for success. When I do that, I didn't plug it in. Of course, when I do that, I get 0.088. Alright, what's the probability that he hits at least 4 times? So at least 4 means 4 or more, right? So I'm going to use CDF, right? Binom CDF. You're still making 10 throws, probability still 0.8. You can actually do a lower bound, upper bound here. So I want 4 to 10, because the most you can get is 10. When I plug that in, I get something. I get 0.99. Little Amarillo Slim has 99.9% chance of getting at least 4. I don't know why I think he talks like that. He could talk not like that. So what's the expected number of bullseyes in 10 throws? Well, to find your expected value, it's just n times p. You have 10 trials with a probability of 0.8. So you expect 8. You expect 8 bullseyes in 10 throws. Now hold up there, partner. What if I change this question a little bit? That's a good... What about the probability that his first bullseye occurs in the 4th throw? I changed the question now, though. Now I don't have a set number of trials anymore. I want number of trials. That's bits. Bits, coins, monies. So you're looking for number of trials. That's geometric, guys. Okay. So now I'm going to a geometric. Be careful when you're doing Unit 5 free response questions, or is it 4? One of them deals with this. Geometric PDF, we're looking at 1 point. Now this one's just probability, how many trials you're looking for. So 0.8, what's the chance that his first bullseye is on the 4th row? Which, when I calculate my calculating powers, I get 0.0064. Okay, which makes sense. He's really good. He should get on the first 2 throws, you'd think. All right. What's the probability that Amarillo Slim takes more than 2 throws? I swear I'm okay, guys. So we want 2 or more, right? Or more than 2, so 3 to 10, right? So again, we're just going to do geo. We're looking at trials. Geometric. CDF. Probability. And again, lower bound, upper bound for the number of trials. 3 to 10. I plug that in, I get 0.04, which tells me is a 96% chance of getting a bullseye in the first or second throw. Right? Right. Okay. All right, let's take a look at number 3. Harlan comes to class because Amarillo had beat him at darts and he has to go back to school. Lost the farm. I don't know what I'm talking about. All right, look at this beast. All right, don't look at the actual question. Come on, computer. All right, let's do this. All right, what's the chances he gets more than 5 out of 10 questions right? So we have 10 questions, so that's the number of trials. Each has 5 choices, so that gives us our P. Our P is going to be 0.2, right? 1 out of 5 that he gets it right, just guessing. So what's probability he gets more than a 5? So what's probability that X is greater than 5, right? So you're looking at 5 to 10. So it's a binomial because there's 10 questions. I'm not looking for number of questions. I'm looking for how many right. So I'm going to do binom, computer not now, CDF. I'm going to do 10 trials, 0.2 probability, and I want to know from 5 to 10. Oh no, more than 5. So it'd be 6 to 10, right? I plug that in my calculator, and he's got 0.0064% chance. That's not good. Harlan's gonna have to go to summer school. Now, what's the probability that his first correct answer occurs after the 4th question? So that means he doesn't get 1, 2, 3, or 4 right, but he gets one right between 5 and 10. So now I'm looking for when, not how many, when. So it's a geometric now. So I'm going to do geo met CDF because I'm combining. I need to know 5 and 6 and 7 and 8 and 9 and 10. Probability is 0.2. I'm looking for between 5 and 10 trials to get it. There's a 30% chance. Harlan, this isn't looking good for you, buddy. No, we're still looking at geometric. Your expected value for geometric is 1 over P. How many questions does he have to answer to get one right? So it's 1 over 0.2, which is 5. You expect him to answer at least 5 questions before he gets one right. That's not good. So what's the probability that he gets more answers than expected by chance by guessing? Well, by chance, he has n times p chance, or that's how many you'd expect him to get right. So n is number of trials, 10.2. So you expect him to get 2 right. So what's the probability he gets more than that? Well, now I'm looking at number of answers right now, not number of trials. So I'm going to do binomial CDF. I'm doing 10 trials, 0.2 probability of success, and then I want to know what's chances to scores between 3 and 10, because that's bigger than 2. It's 0.322. All right, guys. I have to go back and re-record the audio from before. I hope this was helpful. So long.